Hello there, my dear students. Welcome to Grade 9 Physics, topic Motion, lecture number 4. Subtopic Acceleration. Learning objectives for today's session. Students should be able to relate between acceleration and velocity and solve numericals based on acceleration. Some of the reference book for the session used in this lecture. To understand this physical quantity named as acceleration, we will do a case study. Consider a car being driven on a straight track for testing its engine. Let a person sitting next to the driver's seat record its velocity after every 10 seconds and noting the reading of the speedometer fitted in the car. Let us say the car starts from place A, where the initial time being mentioned here as 0 second and the object is at rest, so the velocity is also 0 meter per second. So the observer here noting the velocity in kilometer per hour. So this is the observation recorded by the observer. So to understand this case study, we're just going to observe the first column, that is time, and the third column, that is velocity obtained by conversion. As you observed, at every 10 seconds, that is from 0 to 10 seconds, the change in velocity was from 0 to 5. From 10 to 20 seconds, the change in velocity was 5 to 10 meter per second. From 20 to 30 seconds, the change in velocity was from 10 to 15 meter per second. So from 0 to 30 seconds, our observation will be from the data is that after every 10 seconds, there is an increase in velocity by 5 meter per second. So whenever object changes its speed or increases its speed with respect to time, we'll say that that object is accelerated object. So here we can define now what is acceleration. So acceleration is nothing but the rate of change of velocity. So the change in velocity of an object per unit time is the definition of acceleration. As velocity is a vector quantity, acceleration is also a vector quantity. The SI unit of acceleration is meter per second square. So to represent this in a mathematical form, acceleration equals final velocity minus initial velocity. So that will be my change in velocity. Final velocity minus initial velocity, that will be my change in velocity upon time taken. So initial velocity of the object is represented by u, final velocity of the object is represented by v, time taken is represented by t. So here is the mathematical equation for the acceleration of the body, which is equal to v minus u upon t. So remember that v minus u, we will in a statement we can say that it's nothing but a change in velocity. So whenever we talk about change in velocity, we'll consider final velocity first, and after that we'll consider initial velocity. So as per the case study here, so if I'm just talking about the initial point here 0, so the initial speed of the object was, or initial velocity of the object was 0 meter per second, and since I'm considering the object from 0 to 30 second only, so the final velocity was 15 meter per second. So if I want to calculate the acceleration of such object, so it will be 15 minus 0, as 15 is my final velocity and 0 is my initial velocity, so change in velocity will be 15, and the time taken, the total time taken will be 30 seconds. So 15 upon 30 is half. So My final answer will be 0.5 meter per second square. As you are aware of, that velocity SI unit is meter per second, and the time is in the denominator, so meter per second into second it will be, so second into second is second square, so hence the SI unit for acceleration is meter per second square. Uniform acceleration: when a body travels in a straight line and its velocity changes by equal amounts in an equal interval of time, it is said to have uniform acceleration. So mathematically, this definition also you can write: a body is said to have uniform acceleration if the rate of change of its velocity remains constant. We'll take the similar case study, same case study to understand this. Uh, so uniform acceleration, as we have considered here, the object initially was at point A and finally at point B. So from A to B, we are considering this case. So at A, the object was at rest, so initial velocity was 0 meter per second, and at point B, the object velocity was 15 meter per second, and so the time taken was to reach from 0 to 15 meter second was 30 seconds. As the definition stated, at equal interval of time. So if you observe, the difference in time is 10 seconds, and the change in velocity, the amount of change in velocity is also equal. The change in velocity, the keyword is change in velocity, is also equal, that is 5 meter per second. So if you calculate for any point, that is from 0 to 10 second, or 10 to 20 second, or 20 to 30 second, the acceleration of the object will be constant, that is 0.5 meter per second square. If I want to calculate from 0 to 10 second, I will take 5 meter per second as my final velocity. I will take my 0 meter per second to be its initial velocity, and the time taken by the object was 10 seconds. So 5 upon 10 is 0.5 second. So again, if I want to calculate for 0 to 20 second or 10 to 20 second, we'll find that the answer is constant, that is 0.5 meter per second square. So whenever object changes velocity in an equal amount with respect to time with an equal interval, such object is said to be in uniform acceleration. So this object from A to B shows uniform acceleration. Some examples of uniform acceleration: an object falling freely under gravity has uniform acceleration. As you must be aware of that, the acceleration due to gravity is 9.8 meter per second square, or sometimes it's also considered approximately we take as 10 meter per second square. So that is an example of uniform acceleration whenever body is under free fall. A body moving down in an inclined plane has uniform acceleration. So here the surface here consider as same from all the place. So in that case only, for the inclined plane, an object will have a uniform acceleration. Non-uniform acceleration: when the velocity of the body changes by unequal amounts in equal interval of time, it is said to have non-uniform acceleration. Mathematical definition for that will be: a body is said to have non-uniform acceleration if the rate of change of velocity is different at different points of time during its motion. So let us take the similar case study, same case study, to understand non-uniform acceleration. Now consider a case for C to F. For C to F, so the object initial velocity was 15 meter per second, and final is 0 meter per second. So from C to F, if you observe, there's a interval, the time interval is equal, that is from 40 to 50, 50 to 60, and 60 to 70. So every 10 second, the observer is recorded the velocity meter per second. So he observed that, the observer observed that the object was moving initially with 15 meter per second, then the speed increases by 10 meter per second, that is it was moving with 25 meter per second. After that, the object speed decreases by 15 meter per second. So there was increase in 10 meter per second, and then again decrease in 10 meter per second, and finally there is a decrease of 15 meter per second. So this is an example of change in velocity with respect to time. So such object shows non-uniform acceleration. Here you can consider an example, any object or like a car moving in a traffic road. So it will definitely, the velocity will be, the change in velocity will be with respect to time will be not constant, and such object we say that it's a non-uniform acceleration, since the change in velocity is not constant. If we compare with the uniform acceleration, that is from point A to B, you observe that the change in velocity was constant, that was 5 meter per second in equal interval of time. Now, a very important point to remember, whenever object is moving with constant velocity, that is change in velocity of that object for any given interval of time is 0, then the acceleration is said to be 0. Now that means whenever the initial and final velocity is equal, that means the object is moving with uniform velocity or constant velocity. In such case, we will say that the object is not accelerated, and in such case the value of acceleration will be equal to 0 meter per second square. Since initial velocity will be equal to final velocity, I will take the similar case study to explain this point. As you can observe, for point B and C, there was an increase of time, that is 10 meter per second, but the object was still moving with 15 meter per second. So whenever the object is moving with a constant velocity, in that case we will not say that that object is accelerating, as the value of acceleration is equal to 0 meter per second. Here remember that we have taken this case study in such a way that the object is moving in a straight road, object is not changing any direction. Okay, so that also you need to remember that. Since now we have understood the concept of acceleration, let us see some comparison between velocity and acceleration. Okay, so velocity is defined as the body, that is the velocity of a body is a distance traveled by per unit time in a definite direction, while acceleration is the rate of change of velocity of a body with respect to time is called acceleration. So here's the formula for velocity. Velocity is equal to displacement upon time. Acceleration is equal to change in velocity upon time taken. When the body is not moving, that is at rest, its velocity is 0. That means if there is no displacement, then velocity is 0. When the body is moving with a constant velocity, its acceleration is 0. So this third point for velocity and acceleration is very important. SI unit for velocity is meter per second. SI unit for acceleration is meter per second square. Consider the object is at point D and is moving with velocity 25 meter per second, and that object has applied brake. Since the car has applied brake, so as a result there is a decrease in speed. So whenever there is a decrease in speed or decrease in velocity with respect to time, we say that term to be negative acceleration or retardation. So how it is negative acceleration? Let us keep that in mind, that at E point the object is 15 meter per second, and at D, at initially means the object was moving with 25 meter per second, and the final velocity of the object is 15 meter per second. We have considered only for point D and E. We'll see this case now. So as per the definition, when the velocity of a body decreases with time, its acceleration is negative, and such terms are called as retardation or deceleration. In this case, the final velocity of the moving body is less than the initial velocity, as the final velocity, in the case which we just observed was 15 meter per second, and the object initially was moving with 25 meter per second. So as a result, as v is less than u, or u is greater than v, that means initial velocity is greater than the uh, final velocity. Initial velocity is greater than the final velocity. In such case, the acceleration which we will get will be in negative quantity. Now, question number 1 is already solved, and all this question is available in your NCERT textbook of page number 103. So, question number 1 is, we have discussed this topic already. We'll solve question number 2. A bus decreases its speed from 80 km per hour to 60 km per hour in 5 seconds. Find the acceleration of the bus. Now, I will tell you how to solve this kind of numericals. So first, we will mark the keywords here. A bus decreases its speed. So it was traveling, the speed it was traveling initially, it was 80 km per hour. Okay, as kilometer per hour is a unit for speed or velocity, so we'll consider this as velocity, to 60 km per hour. It changes the speed from 80 km per hour to 60 km per hour. So initial velocity will consider as 80 km, and finally the bus was moving with 60 km per hour. So final velocity is 60 km per hour. So it took 5 seconds to do this change. It took 5 seconds. So this is the information which I've read. That means in the question, V is given, U is given, T is given, and as you know the formula, A equals V minus U upon T. So this formula you should keep in your back of your mind. This formula you should always remember. So I will just suggest you to have this habit that write all the formula as we keep on deriving from speed, velocity, average speed, now acceleration. So there are a lot of formula in this physics of grade 9. So you need to remember formula in order to solve the numericals. So if you remember this formula, it's very easy. Now you have to just substitute. So before substituting, we'll write, let us write this in the given format, whatever we have just collected the information. So now we have written all the information that we have just collected from the question. So initial velocity is 80 km per hour, final velocity is 60 km per hour, time is 5 seconds, and we need to calculate the acceleration of the bus. Now before just substituting the value, we need to see here that final velocity is 60 km per hour. It is not 60 meter per second. It's not following SI system. It's not following international system units. So we need to first convert this initial velocity and final velocity in meter per second. Then only we can solve this question, because time is given in second, or else you can convert time into hour. But I will suggest you that since we are following an SI unit, let us convert initial velocity and final velocity in meter per second, and then after converting, then we'll substitute the value. So if you want to convert initial velocity to meter per second, so you can directly, if it is kilometer per hour, you have to just convert it into meter per second. You can directly multiply by 5 by 18. Now I will tell you why 5 by 18. I will just tell you now. So as you are aware that 1 kilometer is equal to 1000 meter, and 1 hour is equal to 3600 seconds. Okay, so I will multiply this whole 1000 upon 3600 into 80 to get the final answer in meter per second, as we are converting kilometer per hour to meter per second. So instead of doing this simplification again and again, I will just say you can simplify this first only, that is 1000 upon 3600. If you simplify 1000 upon 3600, you will get 5 by 18. Okay, similarly for 60 km per hour, also we can directly multiply 60 into 5 by 18. So this saves a little bit of time. If you remember that kilometer per hour or meter per second ka relation kya hai, will come to know this 5 by 18. Okay, so whenever question, in the question it is given kilometer per hour, you have to convert it into meter per second. You have to just multiply the given value with 5 by 18. Okay, so after converting, the value which I got is initial velocity is 22.22 मीटर पर सेकेंड, दैट मीन्स 80 किलोमीटर पर आवर. अगर हम लोग कन्वर्ट करते हैं मीटर पर सेकेंड तो उसका वैल्यू होगा 22.22 मीटर पर सेकेंड. सिमिलरली 460 किलोमीटर पर आवर को अगर हम लोग कन्वर्ट करते हैं in meter per second, so the value is 16.667. Now, since we have converted in SI unit, all the terms are in SI unit, we can substitute the value. While substituting the value of final velocity and initial velocity, you need to be very careful, as you can make mistake here in substituting and the final answer may be changed accordingly. So here final velocity is equal to 16.67 meter per second. So V here is equal to 16.67 meter per second, and my initial velocity is 22.22 meter per second. So initial velocity of the bus is 22.22 meter per second. So here in this case the initial velocity is greater than the final velocity, as there is a decrease in speed, and we have learned that whenever there is a decrease in speed with respect to time, the physical quantity is referred as retardation, deceleration, or negative acceleration. Since here initial velocity is greater than the final velocity, hence we can observe the answer which we have got here is in negative, which is minus 1.11 meter per second square. Hence its negative sign indicates it's a deceleration. That means there is a change in speed, there is a decrease in speed with respect to time. So this is our final answer. A train starting from a railway station and moving with uniform acceleration attain a speed 40 km per hour in 10 minutes. Find its acceleration. So as we know that the formula for acceleration is A equals V minus U by T. Okay, so the information which we need is, we need velocity definitely, and we need time. So in the formula, if you have observed that in the formula it is V minus U, so there is a change in velocity. Now if you observe in the question, there is only one information is provided, only one speed is provided, or only one velocity is given in that question. So there is a hidden information, so we need to understand the keyword here. A train starting from a railway station. So starting here from a railway station is a keyword. That means initially the object is at rest. So initial velocity of the object is 0. The final velocity of the object is 40 km, and the time is given as 10 minutes. So if you follow the SI unit system, we need to convert here time in seconds, and we have to convert 40 km per hour to meter per second. That means that will multiply by 5 by 18 here again. So the information we collected from this question is initial velocity is equal to 0 km per hour. 0 क्यों है? क्योंकि train starts from rest. Final velocity is given in the question, that is 40 km per hour, and time is equal to 10 minutes. Now you can even convert time to hour and you can solve the sum. बस आपका जो यूनिट होगा एक्सेलरेशन में उसमें होना चाहिए किलोमीटर पर आवर स्क्वायर. ठीक है, सिंस हम लोग ऐसा यूनिट के हिसाब से सॉल्व कर रहे हैं, मैं अभी बता दे रहा हूँ ऐसा नेसेसरी नहीं है. सिंस आप लोग फर्स्ट टाइम इस टाइप का सम सॉल्व करें जहाँ पे यूनिट्स बहुत इंपॉर्टेंट है, इसलिए मैं आपको सजेस्ट करूँगा आप यही आदत डालिए कि ऐसा यूनिट में ही रखने वाला आदत डालिए. एज अगर आप जैसे जैसे फ्रेंडली होते जाओगे, देन आई विल सजेस्ट यू कैन यूज एनी सिस्टम विच यू वांट टू फॉलो. आपको जो इजी लगे आप वो फॉलो कर सकते हो, बट यहाँ पे अभी हम लोग फिलहाल ऐसा यूनिट ही फॉलो करेंगे. तो वी विल कन्वर्ट 40 किलोमीटर पर आवर into meter per second. So to do that, we will multiply by 5 by 18. Then after conversion, we will get it for final velocity. We will get it at 11.11 meter per second, and time is equal to 600 seconds. We will just substitute the value in the formula to get the final answer. So substituting in the formula the value which we have just converted, we know now the final velocity is 11.11 meter per second, and since the initial velocity is 0 in kilometer per hour, so in meter per second also it will be 0 only. So finally 11.11 divided by 600, so the acceleration which we get is 0.0185 meter per second square. So this is the final answer. That's it for today. Thank you for watching the video. If you have any doubt, you can post in the comment section. Until next time, stay indoor, stay safe. That's it for today. Thank you for watching the video. If you have any doubt, you can post in the comment section. Until next time, stay indoor, stay safe.